All right, hey guys, welcome back. So we're going to finish up lesson 5.4 by working back through the even problems. All right, so let me present my screen and we will get started. Yeah, I'm on the right screen over there. Entire screen. Present this one. Okay, so as I said, we're working through the evens. I'll work a little bit more quickly through them just because I already kind of explained all the concepts in yesterday's lesson. So today is just a day for you to practice. Feel free to do the problems on your own first, then watch the video and see how you did, or work ahead of me. That's fine as well. All right, so the radical's already isolated. I'm going to cube both sides to start to get rid of that cube root. So I'm left with 5x plus 1 is equal to negative 64. I'm going to subtract 1 from both sides. It's a linear equation, so it's nice and easy to solve. So I've 5x is equal to negative 65. Divide both sides by 5. And you're left with x is equal to negative 13. Do a quick check to make sure it works, which it does. All right, so I'm going to keep on moving along. If it doesn't work, we'll definitely check to understand why, but if it does work, I might kind of skip through that a little bit today. All right, isolate the radical by dividing both sides by 2. So I have the cube root of 13x minus 5 is equal to 5. Now I'm going to cube both sides of the equation to get rid of that radical. So I have 13x minus 5 is equal to 125. And then I'm going to, I ran out of room. I should have pulled it up. I'm going to add 5 to both sides. I'll swing it up here. Add 5 to both sides. So I have 13x is equal to 130. Divide both sides by 13 and x is equal to 10. All right, do a quick check, plug 10 in. 13 times 10 is 130, minus 5 is 125. The square root of 125 is 5. 5 times 2 is 10. It does work. All right. The next one. Okay, I'm going to cube both sides to start because there's nothing outside of the radical that needs to be moved over first. So I have 486 minus 27x cubed is equal to, I can't do math in my head, 27, oh my goodness, 27x cubed. There we go. I'm going to add the 27x cubed to the other side. So I have 486 is equal to 54x cubed. Now I'm going to divide both sides by 54. Trying to isolate that variable. So now I have 9 is equal to x cubed. And then I take the cube root of both sides. So x is equal to the cube root of 9. Okay, a little bit different of an answer, and it does work. So we're going to skip over the check, but it does work. And luckily, when you plug in the cube root of 9, since it's being cubed, the cube root and the cube cancel, leaving you with just a 9 to multiply with the 27. So the check actually isn't as hard as you might think it is. All right, keep on moving along. Okay, for number 8. So now we have two, we haven't seen a problem like this before. Now we have 2 radicals. When this situation occurs, you actually want to move one of the radicals to the other side of the equation. So we're going to move the 3 times the quantity x plus 1 to the other side. Add 3 root x plus 1 to the other side. So now I have the square root of 2x plus 2 is equal to 3 times the square root of x plus 1. And the reason we want to do that is because now when I square both sides, the radicals will be eliminated. So the radicals eliminated here, leaving you with 2x plus 2. On the other side, just be careful. Don't forget you have to square the 3 and square the square root. So the square and the square root cancel, but don't forget to square the 3 as well. So 3 squared is 9, and then I have times x plus 1. Okay, the radical is eliminated, but this quantity still has to stay in parentheses. All right, next step would be to distribute that 9 into the parentheses, so I can finally drop the parentheses. So I have 2x plus 2 is equal to 9x plus 9. Now it's a linear equation. So it went from being kind of a crazy equation to a pretty basic linear equation. I'm going to subtract 2x from both sides. So I have 2 is equal to 7x plus 9. And then I'm going to subtract 9 from both sides. So I have negative 7 is equal to 7x. Divide both sides by 7. Your x is equal to negative 1. All right, we'll double check quickly using mental math to make sure that that works. So x is equal to negative 1 was my answer. When I plug that in, x is equal to negative 1. Oops. All right, so does that work? Negative 1 times 2, that's negative 2. Negative 2 plus 2 is 0. So that's the square root of 0, which is just a 0. Minus 3, and then negative 1 plus 1 is 0. Square root of 0 is 0. And then that's going to just be a big old 0 on that side, and it's equal to a 0. So it does work. All right, good. Let's look at number 10. So this is similar to the last in that there are square roots on both sides. The only difference is there's a plus 2. The other one is being multiplied by 3. Okay, so it's a little bit more work for this one, which I don't quite have enough room for, but I'll just have to maybe I'll start the problem over here. Erase this. Don't look at that. I'm going to use this space so I can work along. All right, so I'm going to square both sides to get rid of the radicals as much as I can. Now, the radical on the right-hand side does just go away, right? You can square the square root and they're eliminated. Over here, though, it's a binomial, so I actually have to FOIL, and that's why this gets a little crazy. So I have the square root of x plus 7 plus 2 times the square root of x plus 7 plus 2, that's on the left-hand side, is equal to the square root and the square cancel, so you're just left with 3 minus x. All right, so over on the other side, when you FOIL, the square root of x plus 7 times the square root of x plus 7, well, that's the same thing as writing the square root of x plus 7 squared, right? Which then the square root and the squares cancel. So when you FOIL and multiply the first two terms, you're just left with an x plus 7. And then you have the square root of x plus 7 times 2. So that's going to be plus 2 root x plus 7. And then 2 times root x plus 7 is going to be another 2 times root x plus 7. And then 2 times 2 is a 4. Okay, so I know it's a little bit more challenging to FOIL than our typical, but think about it for a second and you'll figure it out. So you have x plus 7 plus 2 root x plus 7 plus 2 root x plus 7. They are like radicals. Add their coefficients to get a 4 root x plus 7 is equal to, I forgot the 4 on the tail end. Sorry. Go back. Plus, don't forget this plus 4. Almost jumped over it. Plus 4 equals 3 minus x. All right, so let's do some kind of cleaning up and combining like terms and see what we're left with. Okay, so I have an x on both sides. Let me actually subtract the x from both sides, and you're left with 7 plus 4 root x plus 7 plus 4 is equal to 3 minus 2x. Then I have a 7 and a 4 that I can combine on this side of the equation, just combining like terms. So plus 11, 3 minus 2x. All right, then I'm going to subtract the 11 from both sides because I have a 3 over here that I can combine with. Oh, I'm getting too low. All right, so on the left-hand side, I'm simply left with a 4 root x plus 7. And on the right-hand side, I'm left with a negative, why can't I do math in my head? 8, 9, 10, 11, negative 8. Yeah, negative 8 minus 2x. Oh, now I'm out of room over there. Let me try that again. So I have a 4x plus 7 equals negative 8 minus 2x. 2x, that's an x over there, 2x. Okay. So now I still have a radical, which means I again have to square both sides. Okay. So don't forget you're squaring the 4 and squaring the radical. squared is 16. When you square the radical, the exponent and the radical cancel each other, so it's just x plus 7. And on the right-hand side, I have to FOIL. You know what? I need more room. Let me erase all this. And write down what I have. So I have 16 x plus 7 on the left-hand side. On the right-hand side, I have a negative 8 minus 2x that I have to square. Okay, so that's where I am right now in the problem. All right, so when I square that, remember that means you have to FOIL it because it's a binomial. So I'm going to write it out. Negative 8 minus 2x, negative 8 minus 2x. So I have 16 x plus 7. Negative 8 times negative 8 is a 64. Negative 8 and a negative 2x is a plus 16x. Negative 2 times negative 8 is a plus 16x. Negative 2x times negative 2x is a positive 4x squared. Distribute the 16 into the parentheses. Hold up a second. Why do I have a 16? Nowhere else is there a 16. Did I make a mistake? It should be a 4. Seven, 8, 9, 10, 11. 11. Oh, okay. I think I just went through it a little bit differently. That's okay. Oh, because I divided both sides by a 4. Should I go back and do that? No, we're going to keep on moving through. Yeah, it should work. Hold up a sec. I did something differently on my answer keys. That's why I'm just was checking my work, making sure I wasn't making mistakes and the answer's not matching up exactly, but I think it'll still work out. All right, so distribute the 16. So it's 112 equals 64. And then combine like terms here, 32x plus 4x squared. Okay, so right now I can see that it's quadratic because I have that x squared term, which means I'm going to want to set it equal to 0 and then try to see if I can factor it or see what needs to be done from there. So I'm going to subtract a 112 from the 64 and subtract the 16x from the 32x. Okay, so that this side of the equation is a 0. So I have 0 equals 64 minus 112 equals negative 48. And then plus 16x and then plus 4x squared. All right, I'm going to rewrite it, just kind of flipping it all around. So it's 4x squared plus 16x minus 48 equals 0. Okay, there is a GCF to pull out, so pull that out first. The GCF is a 4, so I have x squared plus 4x, and then minus 4 goes into that 12 times. All right, so then from there, I'm looking for two numbers that multiply to negative 12 and add to a positive 4. So I'm going to have a 6 and a 2, it looks like. 6, positive 6, and negative 2. Set each factor equal to 0. X plus 6 equals 0. X minus 2 equals 0. All right, and then solve for x. So I have x equals negative 6. X equals positive 2. All right, those are the correct answers. And actually, looking at my work now, I think this was actually the easier way of doing it because the way that I did it, I ended up with like fractions and it wasn't so fun. So even though it threw me off for a second that it wasn't matching my answer key, I think it was a better idea to go through it this way. All right, so before we say we're done though, we have to check our solutions. So again, the solutions so far are negative 6 and positive 2. X equals negative 6, x equals positive 2. If I plug a negative 6 in, negative 6 plus 7 is 1, square root of 1 is 1, 1 plus 2 is 3. Over here, if I plug a negative 6 in, 3 minus negative 6 is 9 because it becomes plus 6, and then the square root of 9 is 3. So this one does work. That's good. Now I need to check 2, see if 2 works. 2 plus 7 is 9, square root of 9 is 3, 3 plus 2 is 5. Over here, plugging a 2 in, 3 minus 2 is 1. The square root of 1 is 1. So that would not work. So that's a false solution. All right, so that one was a little bit of a longer, crazier problem, but just be careful and take your time and you'll be fine. All right, I think I just have 2 more problems that I want to do on the next page and then we'll be done. Lesson 5.4. All right, so for number 12, remember the goal here is to isolate as much as we can the part of the problem that has that fractional exponent and raise both sides of the equation to the reciprocal exponent, okay? So I'm going to subtract 28 from both sides to start. So I have 6x plus 10 all raised to the 7/3 is equal to 128. Now, because I have an exponent of 7/3, I'm going to raise both sides to the 3/7. So it's 6x plus 10 raised to 7/3, and I'm going to raise that entire thing. So I'm going to put brackets to the 3/7. And that's equal to 128 raised to the 3/7. Whatever I do to one side, I have to do the other. The 3/7 is 7/1, right? Multiplied just a 1 because it would be 21/21, which simplifies down to a 1. So I have 6x plus 10 is equal to, now the seventh root of 128 raised to the third. So if you want to rewrite it, it's the 7 root of 128. And then raised to the third. The 7th root of 128, and you might not know this, you might have to do a factor tree, is 2. So I have 6x plus 10 equals 2 to the third. All right, 2 to the third is going to give you an 8. So it's, oh, gotta erase. So now I have 6x plus 10 is equal to 8. Okay, that's what I have so far once I evaluate that exponent. Now I'm going to subtract 10 from both sides. So I have 6x is equal to -2. Divide both sides by 6. X is equal to -2/6. Simplify. X is equal to -1/3. Okay, and it does work. We're going to skip the check. It does work. All right. The last one is number 14. Be careful here. Think about your solutions. If needed, to think about any kind of rejectable solutions that you might be obtaining. All right, so raise both sides to the third. Cube root cancels. You have 2/3 x plus 1 is less than 2/16. Subtract 1 from both sides. So I have 2/3 x is less than 2/15. And then I'm going to multiply both sides by the reciprocal fraction, which is 3/2. 3/2. All right, so you have x is less than, I'm going to just leave this in decimal form again so we can think about the numbers, 322.5. Now, we always have to think about rejectable solutions with these types of problems. Keep in mind it's a cube root. So ask yourself, are you allowed to have positives under a cube root? Can you take the cube root of a positive number? Can you take the cube root of a number like 8? Yeah. Can you have a 0 under a cube root? Yeah. Can you have a negative under a cube root? Yeah. So there are no restrictions. X can be any number less than 322.5 because it's okay for X to be negatives. So for these problems, you really mostly have to think about the restrictions when your index is even. So if you remember yesterday, we did have restrictions on both 13 and 15 because my index is even. And when you solve and you get something like x is less than or x is less than or equal to, because that means x could be a negative. And since we know when the index is even, you can't have a negative, those are the situations where you have to think about the rejectable solutions. Okay. All right, guys, that is it for lesson 5.4. I will see you back here for lesson 5.5. Bye.